Thanks, Nikolai, and thanks to all of you for dialing in and listening to our webinar today. We're super excited about automation. Of course, with the Evosep 1, where we have a high throughput, we also need to produce a lot of samples, and of course, we need to eliminate variations in the sample prep. And here we believe that automation is necessary. So a typical workflow in proteomics would be a sample which would be digested and then separated by the LC and analyzed by the MS. And I think what we all would like to do with faster gradients is that we can now analyze large sample cohorts, where we can include more replica, more conditions, and also go towards clinical proteomics and ultimately clinical diagnostics. And if we want to do this, we need consistency, and we need the workflows to be simple with as few steps as possible, and we will need standardized methods and protocols. And our attempts to standardize proteomics was introducing the Evosep 1, which is really built for standardization and provide reproducible results. And this is illustrated here by our reproducibility. This is from our 100 samples per day method, where we're proud of our run-to-run reproducibility of around 0.9 seconds, measured from 10 replica injections. And also the column is also essential. And here we also have a really nice column-to-column variation. So if one needs to change a column during measuring a large sample set, we can actually still achieve a high reproducibility. And also, when we really want to scale up and compare between instruments, we also have a really nice instrument-to-instrument reproducibility. The aim of the Evosep 1 was also to reduce system overheads so that we are able to do high throughput analysis, but also with a nice proteome coverage, and while still having a good robustness. So the cornerstone of our technology, that's really the Evotip, which serves as a disposable trap column. And with this, we have integrated the elution with the liquid chromatography. And one of the very nice features of the Evotip is that it serves also as a reproducible and sensitive storage for peptides. And we did an experiment here where we looked at the stability of peptides over days up to 1 month. And we see that for different loads, here 5, 50 and 500 nanogram, we actually have a really nice reproducibility, or a very nice storage of the peptides on the Evotip, and something which we believe would not be feasible in a plate to the same extent. And then there's also the advantage that we can actually transfer low sample volumes in rather high volumes and concentrate them on the Evotip, and again store them quite well. So what we would actually like to take advantages of is this reproducible and sensitive storage, and see if we can integrate the Evotip even more in the sample preparation workflows, and thereby simplify them even further. So there are a number of robotic solutions, and this is just a few of them. Philip already described the Bravo from Agilent, and the work in this presentation will be based on the Kingfisher and also the Opentron. So the work here is done in close collaboration with the Jesper Olsen group at the Novo Nordisk Foundation Center for Protein Research, and Florian, who has been doing a lot of this. So in their group, they have streamlined their workflows on the Kingfisher with the pack digestion, where they make use of magnetic beads, which are really easy to scale up on robotic systems. So the workflow they have is fully automated on the Kingfisher, and here they take advantage of the soluble proteins, which can aggregate when we expose them to organic solvent, and then afterwards precipitate on any magnetic microparticle. And that way we can effectively wash away everything and do a very effective on-beat digestion. So the workflows they use for protein digestion and phosphor enrichment on the kingfisher is actually described in the app note, together with recent biosciences you can find in our literature room. So the kingfisher it's very fast. It also works with the 96 samples at the time, where the positions rotate. So you use one sample plate per buffer. One cannot integrate any custom labware, so it's very fixed, but it's in the medium price range, so it's really been a workhorse in the lab. But what we want to move into is the Opentron, because it's much more versatile. You can configure this to any way you want. It's basically just a mix. You can mix and transfer using pipettes, and then you can do whatever you want. So we can integrate custom labware, which we will take advantage of. On the downside is that it runs with an 8-channel multi-channel pipette, so we can only process 8 samples in parallel. So of course there is an issue with speed compared to the kingfisher and also the Bravo illustrated in Philip's talk. But on the other hand, it's very cheap, and it's nice to get started with. So what we want is to integrate the Evosep loading and transfer the pack workflow from the kingfisher to the Opentron, so we can have a fully automated end-to-end workflow. So our first experiments on this was to see how many washes we need to perform in order to get an effective digestion, because obviously every wash takes time when we only operate 8 samples at the time. So our default workflow contains 5 washes on the kingfisher, 3 with acetonitrile and 2 with ethanol. But we see when we challenge the timings, when decreasing the number of washes, we actually remain with the good IDs here measured on a 60 SPD with DDA. And even more important is that we keep our good digestion efficiency. So 88% of the peptides are fully cleaved, despite using less time to wash before the digestion. Another important factor is that the time used for digestion. I think it's quite typical to do an overnight digestion at 37 degrees, but we wanted to see if we could decrease the time and even make use of room temperature digestion. It is possible to implement a heating module on the Opentrons, but we also wanted to be more flexible and see if we could avoid the heating module to take up space on the robot. So we decided to challenge this by different times, so 1, 2, 4 hour, and compared with 14 hour at 37 degrees, and also saw if assuming that the 1 and 2 hours would be too short, could we then circumvent it by increasing the temperature to 47 degrees. And then we compared with room temperature at 4 hours and also overnight. And we were quite pleased to see that ID-wise, we are all on the same level. This is again measured by 60 samples per day with a 50 microgram HeLa input, protein input. But again, it's important to monitor the miscleavage rate as a measure of the efficiency of the pack digestion. And we see that the best digestion efficiency we have at overnight digestion is 37 degrees, but actually room temperature at overnight provides similar results. And I think more interesting is that a 4-hour digestion at room temperature actually gives us quite decent results because we have such an effective on-beat digestion with the pack workflow already. So with this, we wanted to scale up the workflow and see if we could get reproducible results. So we measured 48 technical replicates, all digested on the Oventron, with 50 microgram HeLa protein as input. We measured it with 100 samples per day in DIA mode, and we're quite pleased to see that the identifications are very similar. So a bit more than 3,500 proteins were identified. And here we loaded 500 nanogram, expecting that we don't have a loss in our digestion protocol, which we most likely have, but we didn't quantify it. We just measured it by volume. And it's also nice to see that we have a nice correlation between the replica. Here we compared the first replica with the replica number 48. So to really, the next step would then be to integrate the Evosep loading, because if we can effectively transfer the peptides on the Evosep as soon as the digestion has been quenched, we can hopefully store the peptides better. So we designed a Evosep loading module, which has an MTP footprint, so it should be able to fit most liquid handlers. It's working by positive air pressure and then a simple open and close mechanism, where we can load 8 Evoseps at the time. And then we have some vision installed so that we can monitor each individual Evosep and then look at the differences in the liquid level when we take the different pictures throughout the loading process, and thereby monitor the loading. And this is a picture of an early prototype which we have been using to generate the data in this presentation. So we basically have a position on the Oventron where we have a box with Evoseps, and then we use the 8-channel pipette to move 8 Evoseps at the time into the loading module, and then we can again with the 8-channel pipette take the sample and load on the tips. And it takes at the moment around half an hour to load 96 samples. So the loading procedure with this loading device is a bit different, because as we all know, it's crucial that our Evoseps don't run dry during the loading process and also after until analysis. So therefore we're using higher volumes. We are using 60 microliter of solvents. So initially we soak the tips in isopropanol on the Oventron, and then we add 60 microliter of solvent A, which we will then push through to a sufficient liquid level. On top of this, we will add another solvent A plug of 60 microliter, and then we will add our sample of 20 microliter in between these two solvent A plugs as a sandwich, and then simply push through the sample, and then again add another layer of solvent A and push that through. It is a bit different from the manual way of loading, so we compared it visualized here, where we looked at 8 samples. It's all loaded from the same vial of HeLa. 8 samples loaded manual compared to 40 samples which we loaded with this loading device. And from 50 nanogram and 500 nanogram, we see that our results are quite similar, and also our variations are looks very nice with both methods, but definitely the automated way of loading works sufficiently. So in order to integrate this entire workflow on the Oventron, as I mentioned, it has 11 decks. So we use up 1 position for this loading device, and then 1 position for the Evoseps. Then we have our magnet, which you can buy with the Oventron, which we make use of with our magnetic beads workflow. And then we have a couple of boxes of pipette tips, and then we use these solvent trays where we can add all the different solvents for each step of the process. So this means that we only use 1 position for the solvents, which is really nice. So as a final experiment, we we tried to do this end-to-end workflow on the Oventron. So from a HeLa digest, from a HeLa lysate, we digested, and then we analyzed them with a 200 SPD, where we loaded 500 nanogram of peptides. So we did a dilution series starting from 25 microgram input protein amount, and then we diluted from down to 1.5, and then again we loaded 500 nanogram based on the fact that we didn't have a loss. But we know that of course at lower input amounts, our loss would most likely be higher. So that's also why we see a decrease in identifications. So the light green represents a manual load of these samples. So we did the entire workflow, loaded the samples with our loading device on the Oventron, reflected by the dark green, and then afterwards we took the remaining sample and loaded manually side by side on another set of Evosep, so we could also challenge our loading with more diluted samples. And again, it's very nice to see that the IDs are completely on par, and this is based on 3 different replica per concentration by peptide and protein. So in summary, I think we are definitely towards standardized workflows with the integration of the peptide loading on Evoseps, with a completely hands-off workflow on the Oventron, starting from a protein lysate. The integration of the Evosep loading ensures the efficient storage of the peptides until analysis. And for some applications like ultra-sensitive workflows, we believe it's definitely an advantage if we can load the samples as fast as possible on the Evosep, because we believe that they're best preserved there. So this workflow is possible to integrate with the more it's possible to integrate other workflows with the direct Evosep loading, such as enrichments or pull-down strategies, and also integrated with the loading. And I have to say that the loading module is not yet commercially available, but we are super excited about it, and we are working to get it finished. And I think the acknowledgements, definitely the Evosep team and the guys doing most of this work, and then to Jesper and Florian at CPR, and also Stoyan and Justin at Risen Biosciences.